Alright, so following up on that last video, I've gone ahead and deleted the NV chip, so I'm going to run sudo tpm server. That recreates that chip there, and then we log in. And so what I've added recently is this hard-coded string, and this is going to be the policy digest, the second one. And as Jared has mentioned, we have the first 4 characters here that represent the size, and then after that we have the actual buffer that's getting filled up. And this is a known one from the last video when I did the PCR extend using this hexadecimal value right here as the input, and then ultimately the resulting policy PCR that came out of it looked like this, and we called it policy 2 in the last video. But here we could take this in as a argument from a string, so the user could probably enter it from the command line. Alternatively, we could write this out to a file, maybe the ski file, if that makes sense. But here's just a small function to do the conversion from here, from this type of string into essentially the same thing we have here, where we have a hex byte array. So we would want to take this 2 characters at a time. So we'd have 2, 0, 0, 0, and so forth. And don't worry about the policy check here. This is just me testing out something earlier. But here we're creating a substring, and in that substring it'll hold 2 different characters. For example, 2 and 0. And then after that it'll hold 0, 0. Then after that it'll hold 0, 2. Then after that, it'll hold 2, 5, 3, 1, etc. And then we have the length of the overall string. And then here we have the expected policy buffer, which is going to be similar to this right here. And if I declare the first 2 characters as 0, it goes through and sets all of the characters equal to 0. So the entire policy buffer at that point is going to be zeroed out, as you can see right here. And then I've just declared a long, and I'm putting in the null terminator for the substring we have right here. So that is going to be in index 2. Whenever we create our substring, it's going to look something like this, where we have the null terminator, null terminator, null terminator. And here, just creating a for loop, and it goes through and increments I by 2, because again, we're going through 2 characters at a time. And on the first iteration of the loop, we're taking the first 2 characters and putting it into that substring. So the substring should look like this. And then we're doing a string to long conversion. This is actually string to unsigned long using base 16. So it'll convert that into a number. And on the first iteration, I believe the number is 32. And 32 represented in hex is 20, 20. And that is what we want inside of the memory address. And then here we're doing the expected policy buffer I divided by 2, because we're incrementing by 2 every time we go through this loop. But when we're populating the buffer, we want to put this in the 0, the 1, the 2, the 3, and the 4. So we're taking the 0th element, putting that long in there, then going to the first index, then going to index 1, putting the long in there, then to 2, etc. So if there's anything wrong here, let me know. One thing I did want to point out is because this says 66, when I had this set to 68, we can see that that it will always overflow because the destination buffer, which is expected policy, which is a TPM2B digest type, has a size of 66, which is why I have 66 here as the size. So let me know if anything looks wrong there. But now you can see we're declaring the TPM2B digest. In the last video, we would call this policy 2, but we're going to call it expected policy here. And all we're doing is a copy from that buffer that we just generated through that for loop, and we can probably put this out in a function, make it a little bit cleaner. But we're filling up the expected policy with that buffer that we created. So now if I run the debugger, and if we look at expected policy and show that in memory view, you can see here we have a total of 68 hexadecimal characters, ranging from here all the way up to here, you can count them. And as we continue on down, most of this stuff is all the same. Here we're creating the first policy, and let me come down here, we have our PCR read, and I'll run this in the debugger. Remember from the last video, the PCR read puts all the values in PCR values. So if I go to PCR values and look in the digest for 0, 1, and 2, they all have a buffer of nothing but zeros. So that's normal because we haven't done any type of PCR extending yet. And everything else here is the same for policy 1. The only real difference is I don't even have a session for policy 2 now. So I just deleted all of that code, because really the only point of running all of this code where we're creating a session and then doing the apply policy and then getting the policy digest is so we can ultimately get that policy, which would be stored in policy 1, And in previous videos, we would also get one for policy 2. But now we have that expected policy that we generated from that user input. So now we have policy OR, and instead of policy 1 and policy 2, I'm using expected policy. And there's a couple other points where we have to write that in. Obviously, when doing the create Kmyth object, we eventually call policy OR. So we're passing in policy 1 and expected policy. And then down here, we do another create Kmyth object, same thing, policy 1 and expected policy. And then coming on down, the last place we need to write that is in the output when we're writing that policies.data file, because that is going to get read in by the seal when we do the unseal. So now if I run the program in entirety, we can see that it does the seal. Everything appears to be working okay. So now let me come to the unseal. All of this code is pretty much the same. We're reading in policy 1 and policy 2. Of course, now policy 2 would be that expected policy that we wrote onto the file. And if we come down here, what I've done is write in a PCR extend, kind of like in the last video. So now we're taking this, again, random SHA-256 digest, and it's represented in hexadecimal. And when we actually, write everything to the Kmyth code, we would not include this. This is only to demonstrate that, everything is functioning as we would expect it to. But here, we're just doing a lot of the same code that we did in the last video for the PCR read and the PCR extend. So we're taking in all these values. This is all the same. One thing I did modify briefly was writing a loop. In the last video, all I did was copy and paste it a couple times. But it is the same code. We have our digest values, the count of those, and we're just going through each one of them and updating the hash to the global constant hash value that we selected. Here we're taking that hexadecimal value and then copying it all into the digest for the 0th element, then the first one, then the second one. And then here we're doing another loop, which is actually extending every one of those PCRs and writing in 0, 1, and 2 in place of I here. And then here we just do another PCR read, and that's all that's different in this code. So now hopefully if I do an unseal, it unseals correctly. Let me go to output, IDK. It does seem to work correctly. Now keep in mind, because I have an extend in the unseal code, and that extend happens before we do the unseal, we actually sealed, and inside of the seal there's another check that we need to satisfy the policy. So when we sealed against the PCR values of all zeros, but now that we've done the unseal, so if I do TPM2 PCR read SHA-256, you can see we have these new values for the PCRs. And those are the PCR values we had when we did the unseal. So if I call unseal one more time, it should extend the values one more time before it tries to do the unseal. And because of that extension, it should fail the policy check. So let me go ahead and try it. And we can see here a policy check failed. And I can go ahead and close this out, clear, run the server, log in real quick. And if I do a TPM2 PCR read, you can see we have all 0 values for the PCRs now, and I can try this unseal one more time, and it worked correctly.